Good afternoon, 6th grade students. I hope you've had a wonderful day at school and are ready to practice some more math. Today we are going to take what we've been learning about fractions to just one more step. We're going to be slightly adding on to what we already know about fractions and solving equations. So we know that in an equation like x minus 1/3 equals 5/6, we know that we have a variable. X is the variable. We don't know at this point what x stands for. However, like the other problems that we know, such as x minus 2 equals 5, we know that we need to add 2 to both sides. So x is by itself. So 5 plus 2, x equals 7. With fractions, it's just like that. We do the exact same process, only with fractions. So x minus 1/3 equals 5/6. I know that I need to get the x by itself. So x minus 1/3, f minus 1/3, the opposite of subtraction is addition. So I'm going to add 1/3 to both sides. So plus 1/3 equals 5/6 plus 1/3. Now I know that minus 1/3 plus 1/3 is nothing. So that gives me the x by itself. Now, 5/6 plus 1/3. Now, I know from Monday's lesson that 6 and 3, they're not the same. So in order to add fractions, I need to have a common denominator. So I know that the multiples of 3 are 3, 6, 9, 3, 6, 9, 12, and so on. The multiples of 6 are 6. Oh, look, I can stop right there. I see that they both have 6 as a common multiple. So my common denominator is going to be 6. 5/6 already has the denominator of 6, so I'm just going to leave that fraction alone. So I have 5/6. Now I need to look at 1/3. I know in order to change 1/3 to have a denominator of 6, I need to multiply by something. 3 times what number is 6? Well, 3 times 2 is 6. So that makes that a true statement. Now I know that if I do something to the denominator, I also have to do the exact same thing to the numerator. So I need to multiply 1 by 2. 1 times 2 is 2, so my new fraction is going to be 2/6. I am now ready to complete my equation. Now, I have two fractions. Both of them have the same denominator, so all I need to do is add the numerators. 5 plus 2 is 7. Keep the same denominator, but oh wait, I see that I have an improper fraction. My numerator is bigger than my denominator. I need to change this to a mixed number. In order to change it to a mixed number, I'm going to divide. 7 divided by 6. 6 can go into 7 one time. 1 times 6 is 6. 7 minus 6 is 1. I have 1 left over, so that remainder becomes the numerator of a fraction. And of course, my denominator stays the same. So 7/6 equals 1 and 1/6. And that would be my answer. X equals 1 and 1/6. Not too bad. It's just taking everything we already know about solving equations and then adding and subtracting fractions and putting them together. It's nothing to be worried about. Let's try another one. N plus 1/3 equals 11/12. Again, just taking everything we already know about equations and fractions. N plus 1/3, see that the opposite of addition is subtraction. So I need to subtract 1/3 from both sides. 1/3 because it's on the same side as the variable equals 11/12 minus 1/3. Now I see 1/3 minus 1/3, that's 0, giving me my variable all by itself. Now 11/12 minus 1/3. Can't do that, can I? Because I know that I need to have the denominators match. They need to be the same number, and 12 and 3 are not the same number. So I'm going to list my multiples. 12, 24, 36. Oh, let's stop there. I'm sure it's not going to be that big. Let's list my multiples of 3, 6, 9, 12. Oh, I can stop. I see they both have 12 in common. So my common denominator is going to be 12. So 11/12, well, that one's already 12, so I can leave that alone. 11/12 minus, now I need to get 1/3. I need to change that fraction so that the denominator is 12. 1/3 times something equals a denominator of 12. 3 times what number is 12? Well, 3 times 4 is 12. Now remember that every time I do something to the denominator, I have to do the exact same thing to the numerator. So 1 times 4 is 4. My new fraction is 4/12. Now I am ready to subtract. 11 minus 4 is 7. Keep the denominator the same. So n equals 7/12. Now I'm going to take a second look at this fraction just in case I miss something. I need to ask myself, is this fraction in its simplest form? Can I reduce it any further? I know that 7 is a prime number, so nothing goes into that to make it smaller, and it can't go into 12 evenly, so I know it's not 1/2. So it is in its simplest form. So my answer is n equals 7/12. Now what would we do if we did not have a story problem in our lesson? During the first week of January, a rain gauge collected 1/2 inch of rain. By the end of the month, the rain gauge showed that the total January rainfall was 2 3/5 inches. How much rain fell after the first week of January? Okay, so I need to look for my keywords here. I know at the first week of January, we had 1/2 of an inch of rain. By the end of the month, we had 2 3/5 inches. How much rain fell after the first week of January? We want to know how much rain. Okay, so now I see the important information, the important details from the story problem. Now I'm ready to figure out how am I going to solve this. I know that we started with 1/2 inch of rain. We ended with 2 3/5 inches of rain. I know that I take the 1/2, add it to what rained in the middle of the month to get to the end. So I'm going to have that as my variable. How much rain fell in the middle of the week, or after the first week of January? That's going to be my variable. That's what I want to find the answer to. Okay, so now I need to figure out what x equals. I know that this is a positive number, 1/2 is a positive number, so I need to do the opposite of that. I need to subtract. So I have 1/2 minus 1/2 plus x equals 2 and, oops, not 2, 3/5 minus 1/2. 1/2 minus 1/2 is 0, so that gives me x all by itself. X equals 2 3/5 minus 1/2. Now once again, I know that I need a common denominator. And to make this easier, what I'm going to do, I am first going to change this mixed number into an improper fraction. So I don't have to worry about the whole number, I can just focus on fractions. Now I know that in order to change a mixed number into a fraction, I need to take the whole number times the denominator and add it to the numerator. So 2 times 5 is 10. 10 plus 3 is 13. Of course, my denominator stays the same. And I'm just copying this over here so I don't forget what I'm doing, what my goal is. So I have 13 over 5 minus 1/2. Once again, I still need that common denominator. So I'm going to list the multiples of 2 and 5 until I get to one that they have in common. So for 2, I have 2, 4, 6, 8, 10, 12, 14. I'll stop there for now. Let's see if that's far enough. 5. I have 5, 10, 15, 20. Oh, I see that I do have one in common. They both have 10. So I know that it looks like I need to change both fractions so that they both have 10 as their denominator. So let's start with 13 over 5. 13 over 5. 5 times what number equals 10? Let me get rid of some of this work so I can see what I'm doing. 13 over 5. 5 times what number equals 10? 5 times 2 is 10, so I need to do the same thing to the numerator. 13 times 2 is 26. Okay, so my first new fraction is 26 over 10. Now, 1/2. I need to change that so it has a denominator of 10. 1/2. 2 times what number equals 10? Well, 2 times 5 is 10, so that means I need to do the same thing to the top. 1 times 5 is 5. So I now have 2 new fractions, and I know this board looks kind of messy, but I hope you can follow along what I'm doing. So I have 26 over 10. Let's see, I know that I was subtracting, so minus 5, 10. 26 minus 5 is 21. And the denominator stays the same. Now I need to look at this fraction. 21 over 10. Is it in its simplest form? It's not. I need to reduce. 21 divided by 10. I know that 10 can go into 20 2 times evenly, and there is 1 left over. So that means x equals 2 1/10 inches. Now I can't forget to label my work. We are working with inches. So inches needs to be in the answer as well. Okay, I'm hoping you won't have any problems with this lesson. It's really, again, just a combination of everything we already know how to do in math. It's just a matter of writing down your steps so you don't lose track of what you're doing. I never would have been able to solve this problem if I didn't write everything down. I would have totally gotten it wrong. So write down every single step so you don't forget what's going on or don't make a silly mistake. So now it's your turn to try. In your textbook, page 198, numbers 1 through 6, and since we're working with fractions, I decided to put a piece of pie on it, because math with fractions is a piece of pie. And that is it, and I will see you tomorrow. Hope you have a great day. Bye.